afternoon. My name is Lisa Velarde. I'm co-founder of Semka, and I'm going to present you a new era for cancer treatment personalization. Cancer is a global problem. Today, there are over 50 million people living with cancer in the world. Of them, 8 million people are going to die each year, mostly for metastasis. The problem is that there is not an effective way to know on time if the therapy they are applying to each patient is working or not, until it's too late. For that, we created a technology that can isolate circulating tumor cells. This is how it works. We take a blood sample from patients, we introduce it here inside this device, and as you can see in the image, the cells enter all mixed up, and at the end of the process, we can isolate the cancer cells that are going up, and the other blood cells are going down. Now, the important here is that the cells at the end of the process are kept viable, which means you can perform a lot of studies with them that are going to give you significant and real-time data. Data that are going to help physicians to prescribe personalized treatment for each one of their patients, increases their chances of survival, and also helping them get cancer-free. We have to market. Our first one are the research and laboratory for drug testing and also for validation. And also our goal market that are the healthcare centers and hospitals. But for that, we need validation from government. There are over 46 companies around the world trying to resolve this problem. The only one approved by the FDA is Slush from Janssen Diagnostics. If we compare our technology to theirs, we have a real cell sorting platform and analysis platform with a label-free approach, which means we are 6 times more affordable. Our business model like the printer and the cartridge, which means you have to buy the analyzer just once, and each time you want to perform a test, you have to buy the biosensor. We have an amazing multidisciplinary team that have been working together the last 4 years. In those 4 years, we have achieved to file 2 under the PCTs. And also, we have built a functional prototype already tested successfully with cancer cell lines of breast, colorectal, prostate, and liver cancer, with over 90% of efficiency. Also, we have started our trials on prostate cancer patients. Also, in those 4 years, we have been granted with 2 government grants, and we have accepted into an amazing accelerator programs like Y Combinator and also Singularity University and Draper. At the end, this technology is going to change the way that we treat cancer patients. And I want you to invite all of you to join us in our goal to make a difference in those people's lives. Thank you.
Yes. Thank you very much. I mean, also a very important topic. I mean, avoiding biopsies in cancer diagnostic is a key aspect. So were you able also to identify these circulating tumor cells from blood? Or I didn't get this fully. Can you maybe explain a bit more? How far are you right now in really being able to isolate these circulating tumor cells?
So what we do is that we take 8 cc's from blood from a cancer patient, we introduce it inside here together with the buffer. And at the end of the process, we can isolate with over 99.9% of the flexion rate. So that means that we can isolate all the cancer cells, and most of the cells are going down. So we can separate the white blood cells that are the more difficult ones to separate and the cancer cells. And we already have the proofs of that.
So how widespread does the cancer need to be before you can detect it? I mean, can you also use this for early detection, possibly? Or what is the stage?
Yes, we haven't been go through that trial right now, but according to other researchers that our fellow research have been done, this technology could also work in stage 2 and also in stage 1, but it definitely works in stage 2, 3, and 4 of cancer, because cancer cells are so small, so little, and you compare them with the whole billions of cells that is in 1 milliliter of blood.
with the right level of investment, what would it take between the cost of production and then your revenue to break even? Like, how much do you need to sell of your devices and to cover the cost of production?
Okay, well, the cost of manufacturing all biochips is around $20. And we need to sell like approximately 1,000 in order to cover the investment that we have received already.
So what kind of help do you need? What are the biggest needs at this moment? Next steps.
Yeah, our next steps. Well, we have already started with our trials on prostate cancer patients. So we're going to do all that. And as you can see in the image, we have the whole big prototype. We want the help of more experienced engineers in order to have it more tailor-made, like this kind of machine that can fit inside of the doctor hospice. It can be done. We only need time in order to do that.
And did you say you're already going to start clinical trials, or
yes,
it's already ongoing, or will it start sometime soon? What's the timeline?
Yes, we are right now in Mexico performing the trials. We already talked to the doctors, and also we already have the patients and the hospital permissions. So we're just about to start in a couple of days. Thank you.